Alright, so what we were talking about in day 29 is the 7 steps for a simulation, and we went through the steps. We have decided that we're repeating the component, opening a box of cereal to identify the toy. We're going to model that by spinning a spinner until it lands on each of the 4 sections, and then afterwards we're going to record in every section it lands on like this, and then count the number of spins, number of boxes of cereal I had to open to get all 4 toys, to get the numbers 1, 2, 3, and 4. The response variable is the number of spins needed to land in each of the 4 regions, which equates to the number of boxes of cereal I need to open to get all 4 toys. Our example of our one trial was right up here, and it took us 8 boxes. So now before we can analyze the results and obtain our conclusion, what you'll be asked to do in your homework is to actually do 10 trials. If they don't specify, I'm specifying you need to do 10 trials. And then what we're going to do is we're going to analyze that and then state our conclusion. Remember, we are simulating something happening by random chance, okay? We are simulating something happening by random chance, okay? If it's highly likely, or if it happens due to random chance, it's probably okay that it happens here, all right? So what I have on this next page, I've done 10 trials of my spinner spinning. I've done 10 trials of this until I got the desired numbers 1 through 4. So this was my spins to get toys 1 to 4, and this is my response variable right there, the number of spins. Okay, so I had 15, 18, 12, 8, 9, or 8, 10, 19, 5, 13, 17, and 12 that it took me to get all 4 toys. So now I want to analyze my results, and I want to do this in a picture. So I could just do a little dot plot. Dot plots are nice for little small amounts of data. So it looks like I basically started at 8. And I had 15 once, and 18, I can just put dots, and 18, and 12, and 8, and 10, and 19, and 7, 6, 5. Okay, so there's 5, and 13, and 17, and 12 again. So this is just a dot plot. They're kind of spread all over the place, but here's the deal. This is the desired number. We're looking for the probability that x, this being our x here, all of these number of spins being our x, the probability that x was greater than or equal to 15 boxes of cereal. So that's what we're looking for. So out of 10 trials, how many of these were greater than or equal to this? That was 4 out of 10, or 40% of the time I had to open 15 or more boxes by random chance. So this means that 40% of the time I had to open 15 or more boxes to get all 4 toys. So now we need to make a conclusion. Okay, so this was step 6, analyze. And now step 7, conclusion. Because it took greater than or equal to 15 boxes to get all the toys, by chance alone, we should not accuse the company of lying. which is the question you were asked at the very beginning, was the company lying? Alright, so we have one more of these examples to walk through, and we're going to go through this one a little bit faster. And although, let's answer these questions here first. If it took me 20 boxes to find all 4, would that be convincing evidence against the company? Well, let's go back and take a look at our chart of our trials, because our same trials should be just as good here as they would be to answer that question. So in how many of our trials this time, if we were answering the question, the probability that x is greater than or equal to 20, what would be our probability there? Well, none out of the 10 took more than 20 boxes. So 0% of the time I had to open 20 or more boxes to get all 4 toys. So in this case, if it took me 20 boxes, would that be convincing evidence against the company? Yes, since 0% of the time it took me 20 plus boxes to get all 4 toys. So now the next thing, it just says, how else could we model the outcome in step 2? Well, we could roll a die and we could skip 4 and 5. That would be good. We could actually use a deck of cards and note the suit, and each time we'd have to put the cards back so we were always drawing out of the same number. So each of the suits could represent a 1, 2, 3, or 4. Random digit table. You could skip 0 and use the digits 5 through 9, or we already talked about 0 to 24. We could do random integer 1 to 4 and just keep hitting enter until we get the numbers 1 through 4. Alright, so now we want to look at this problem here. We've got an ESP problem. A person who claims to have ESP says that she can identify the symbol on the back of a card, a circle, a triangle, or a square, without seeing it. To test this claim, you shuffle 3 cards and show her the back of a randomly selected card. And if she correctly identifies the symbol, then you replace the card, reshuffle, and repeat this procedure 19 more times, 20 total. Overall, she identified 10 correctly. Does this support her claim of ESP, or could this have occurred by random chance? Use a simulation to estimate the probability of getting 10 or more correct by just guessing. Use a random table random digit table. Alright, so what are we repeating? So step 1, we're going to simulate this. We are repeating identify the symbol on a card. That's what we're repeating. That's what we are pretending to be. That we're simulating being the person that claims to have ESP, and we're going to identify the symbol on the card. 2, how are we going to model this? We've got 3 different cards. It says that we've got a circle, a triangle, or a square on the back of each card. And we're assuming that each of these is equally likely to happen in this deck. One of 3 cards. So let's just use a random, we could use a random digit table, and so we would have the digits 0 through 9. Okay, so we're going to have the digits 0 through 9. And we want to identify, let's see, that means that 0 through 9 would be 10 digits. So we're not going to use 0, we're going to skip any zeros. And we're going to let 1 through 3 be the correct answer, and 4 through 9 be the incorrect answer. Now the reason we have to do that is because each of these has 1/3 chance. She has a 1/3 chance at any given time to get the correct answer. Okay, a 1/3 chance, 1 in 3. So if we have 9 digits or 10 digits, we only need 9. And so on any given guess, only one of these is correct. So only 1/3 is correct, 2/3 are wrong. So of the digits 1 through 9, 1 through 3 would be correct, and the rest of them would be incorrect. So now if we get a random digit table, which we're going to use just this one right here, and what we want to do then, well, this is how we're going to model it. So I guess let's continue with component 3 first. So a trial. So a trial is she has to have 20 guesses. So we need to look at 20 random numbers, random digits, and identify if correct or incorrect. For the response variable, okay, the response variable is the number of correct guesses. Number of correct guesses out of 20. So we're going to count the number of 1 through 3s that we get. That's how we're going to count the correct guesses. All right, step 5, we're going to give an example. And actually, I'm also at this time just going to do my 10 trials. I'm just going to do my 10 trials so it's easy and I can analyze my results then. So I'm just going to do my 10 trials right on here. I'm just going to use a little pencil. All right, so maybe I'm not going to use a pencil. Maybe I don't have a pencil. Here's pencil. Okay, so let's see. This would be, I may not have enough. I might have to pull out another random digit table from somewhere, which might take me a second. Let's see. I bet my stats book has random digit tables in the back. All right, so actually I found a random digit table in the back of my book. So I'm just going to use this, and I'm just going to go, let's see, this would be 5, 10, 15, 20. So I'm just going to actually use these first things, and I'm just going to do 10. So this would be, I'm just going to basically count the number of correct here. So there would be 1, 2, 3, 4, 5, 6. So in my first trial, I got 6 correct. So in trial 1, I'll just keep writing them here, 6 correct. And then in trial 2, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I'm just going to continue doing this. I'm going to pause the video. When I come back, I'll have it all done. You could do the same thing here. You have the same random digit table. Okay, so I guess there was, when I first showed you this, basically, what we have to do, since we're skipping zeros, notice I have 1 0, 2 zeros here, so that means I have to go over to 2 more here, because we don't count the zeros, they don't count as anything. So instead of 6, then I would have 8 in the first one. And so anytime like here there was 2 zeros, so I had to go over and there would have been 1 more trial. So for however many zeros, you just have to keep going over to get all the 20 digits. But I did that, and this may not be perfect. I did it kind of quickly, but here's our 10 trials. So this, basically, these are the number that I got correct out of 20 each time. Okay, so the results, well, this was our example in our 10 trials. Now step 6, we're going to do the results. So out of 20 guesses, out of 20, we got anywhere between 4 All right, so I had 8 and 10 and 8 right and 4 right and 6 right and 6 right and 7 right and 10 right and 8 right and 5 right. So, in order for her to have ESP, what do you suppose I mean, I would want her to have at least 50% right, wouldn't you? So really, I guess what we're looking for, I mean, how do we tell if a person has ESP? Well, what's the probability that X, the number that they get right, the response variable, the number of correct guesses, is greater than or equal to, I would have to say at least 10. I mean, we'll just give them the low. Okay, so that's how I would determine whether or not they had ESP. Okay, so how many times did that happen? That happened 2 out of 20, or 1/10 of the time, or 10% of the time. So I would have to say no, probably not ESP.